Welcome to this special thought leadership session of the GRETEC Innovate to Build event to embrace the future and exchange on new technologies that will change the way structural engineers are nowadays managing their projects. My name is Joseph Pais, Chief Product Officer at GRETEC. I'm a structural engineer with more than 25 years experience in the AEC industry. I joined GRETEC and the software industry at the end of the 90s. And it is amazing to see how numerical tools, how the BIM have been significant steps ahead in this industry. In the 90s, we have seen the first FEM softwares coming as FL from GRETEC, having a graphical interface and changing the way structural engineers are working. All detailers adopting CAD softwares for detailing, companies adopting BIM workflows and build better and faster and collaborate together. But this is nothing comparing to the technological revolution we are facing right now. Much more focused on data being really disruptive. But before starting this amazing journey, Rawad, can you introduce yourself?
Thank you, Joseph, and welcome to this special thought leadership session. My name is Rawad Asaf, Simulate Director at GRETEC EMEA, structural engineer and PhD with 20 years of international experience in the AEC industry, from design to execution through management and education. During our time together today, we are going to be looking at some advancements in structural engineering. We will treat in this session 4 main topics: AI in structural engineering, retrofitting techniques and sustainability, the new era of industrialization, data and software in the cloud. Artificial intelligence in structural engineering involves computational methods aimed at emulating human cognitive capabilities to solve engineering problems. Machine learning utilizes computer algorithms to autonomously improve performance through experience, enabling the development of computer programs capable of accessing data and self-learning. In the construction industry, ML holds the potential to enhance safety, productivity, and quality. As structural systems, analysis procedures, and modeling become increasingly complex, there is a growing demand for rapid prior knowledge concerning the pre-sizing and initial configuration of structural elements. AI and ML can provide quick and reliable estimations of these parameters, significantly facilitating preliminary design and project feasibility assessments. Moreover, AI finds application in structural health monitoring, known as SHM, a field undergoing intensive research in structural engineering. SHM encompasses 2 main categories: image-based SHM, leveraging computer vision technology, and vibration signal-based SHM, utilizing signals acquired during dynamic events. The latter can be further categorized into parametric system identification, model parameters identification, and non-parametric system identification. ML algorithms have been used extensively in both types of SHM. I would like to place here an important statement. Artificial intelligence is ready to start to revolutionize our construction industry with new ways of designing, analyzing, optimizing construction projects, whatever the type or complexity of the project. We are talking here about a few months time frame and not few years. Joseph, do you see more specific applications for AI in our industry and in GRETEC's products?
Structural analysis softwares are not new. And structural engineers are using such tools on personal computers since more than 80 years, having in mind that the FEM method was invented around 1940. Nowadays, computers have significantly improved their capacity for calculating important and complex 3D models more and more faster. Despite this, the real job of structural engineers did not really change, even if automated in some areas. As I mentioned before, first FEM softwares having graphical interfaces for 3D inputs were launched beginning of the 90s. Those softwares have generalized the use of finite elements method, opening new amazing possibilities to solve complex problems. At the time being, what engineers still expect to do hand calculations? None, except to control some order of magnitudes, to check some results, and avoid big mistakes. So no doubt that thanks to the ever-growing capacities of computers and the new softwares, we can calculate bigger and bigger models in less and less time. But a structural engineer still have to calculate all the elements of a model to get the project done. And the time it takes limits the number of variants being analyzed. Another important fear for a structural engineer is the risk of errors, engaging his own responsibility. Again, AI can be here an important help and effective solution to reduce significantly this risk. We can list 3 different AI techniques that might fit quite well with the structural engineering: machine learning, pattern recognition, and deep learning. Those 3 different techniques being strongly linked. Machine learning is the most known subfield of artificial intelligence. If you want to have performant machine learning algorithm, we need to have a good and reliable data. Those algorithms can read and process the data to make predictions for the next calculation. This could significantly change the life of engineers who have to precise a complete project within a few seconds, optimize the size of the elements, but not only proposing a new optimized geometry or species distributions, it's also a service that can be delivered by AI. Pattern recognition is a method that we could leverage to create real-time testing scenarios for our products, especially on structural analysis softwares. Today, at Gretec, we have automatic validation systems able to run every single day thousands of tests to validate the final application, but those tests are defined manually. Another use of the pattern recognition, used in combo with the machine learning, is to detect failure modes, predict results, identify weak points of the structure, eventually empowered by sensors. We are here talking about IoT, Internet of Things. Deep learning, the next generation of algorithms based on neural networks, to learn from past actions, past calculations. Just imagine a software able to learn step by step. The more you use it, the more it will be powerful, helping you to go behind the limits.
Let's go now to retrofitting and sustainability. In recent years, retrofitting techniques for buildings and structures have undergone significant evolution, driven by the increasing demand for urban development to accommodate growing populations and businesses. This demand poses a real challenge in expanding built-up areas within cities. Joseph, how do you describe the relation between retrofitting and sustainability?
Sustainability is everywhere for everyone. For me, retrofitting goes with rehabilitation, structural and thermal. We know that the need of new housing, residential buildings will increase a lot on the next decades. If the construction industry wants to face the demand, we cannot just build new structures, building hospitals, schools, but adapt an existing structure to a new use, retrofitting, and apply a structure and/or sustainable rehabilitation to the existing structure. For me, when we have an existing project to deal with, there are 2 different aspects to consider: the design and modeling part. Nowadays, we have plenty of technologies that can help an architect, a structural engineer, a thermal engineer to model existing projects. Internal and external 3D scans that generate a 3D cloud points models quite detailed. It is amazing to see nowadays how much details we can get from an external scan system and how fast you can get a 3D model you can use to optimize the existing structure. At Gretec, we also have FEM and thermal analysis softwares like Advanced Design or ArchiWizard, able to import a 3D BIM model and run design and calculations to estimate the structural capacity of the elements optimize the thermal performances with STD calculations and lighting analysis. It allows engineers to run and analyze several iterations and get the best retrofitted project. The second aspect is the technical part, with several methods quite well known. Let's just mention two different techniques depending on what you want to achieve. If you want to increase the seismic resistance, you can add new steel bracing elements, reduce the masses, add base isolators, or add shear walls, and so on. To reinforce the structural resistance, you can apply jacketing method, quite popular especially in concrete, add fiber-reinforced polymers like carbon plates, or add structural elements. When you apply a retrofitting process to an existing building, it is important to be aware that you have to compete with the latest regulations, most of the time with higher expectations. And it is important to have tools helping you to do that: step calculations, detailed reports, specific analysis. I cannot talk about retrofitting without talking about IoT. This is an important step to make an accurate diagnostic of the structure and detect the weaknesses. We are in a data-connected era where these kind of workflows are quite usual. Sustainability is also a key point, especially when you want to rehabilitate a project, but also when you build a new one. This is why we implemented the carbon footprint estimation in all our products, and not only in ArchiWizard, our software for thermal and carbon analysis. We implemented carbon footprint estimations in advanced design for the structural engineer to be able to optimize the structure, also using these criteria, and not only structural ones. In advanced workshop as well, our fabrication management system for the fabricators to better estimate and monitor the carbon footprint of their fabrication processes. Rawad, do you want to complete my view on the retrofitting topic, maybe more from the structural point of view?
Thank you, Joseph. Very inspiring. And of course, I can say that throughout my career, I've had the privilege to work on numerous fascinating rehabilitation and retrofitting projects. These projects have ranged from repairing damaged buildings to renovating historical structures and adapting existing buildings to accommodate new users, such as adding floors and accommodating increased loads or meeting new seismic requirements. In such endeavors, the ability to think creatively and approach problems with innovative solutions has been crucial to achieving success without forgetting the necessity to use the adapted tool and processes. Joseph, during a meeting with a client, a Greatech advanced design client, which is, as you mentioned, our FAM structural analysis software, they presented a very interesting workflow to model an existing structure. They used drones to do a 3D scanning of a construction site. This so-called drone model can be converted to a BIM model in Autodesk Revit through a cloud of points, and therefore to FAM model in advanced design because of the excellent interoperability of our solutions within Autodesk ecosystem, and analyzed after adding corresponding loadings. In addition to traditional methods listed in previously by Joseph, I would like to emphasize a retrofitting technique known as external post-tensioning, EPT. This method involves the addition of post-tension tendons externally to the existing structure. It is highly effective for strengthening and repairing existing structures and is commonly utilized in two primary scenarios: strengthening of beams and slabs or seismic retrofitting. The advantages of EPT include lightweight addition to the structure, minor works compared to classical retrofitting methods, avoidance of interference with existing equipment such as HVAC, electrical systems, and lighting, requires relatively low height for installation, enhances structural strength and reduces deflection, and it can be installed without disrupting the functionality of the facility. Joseph, let's talk now about industrialization.
Very interesting topic.
The industrialization of construction processes represents a significant shift in the way buildings and infrastructure are designed, constructed, and operated. This transformation involves the adoption of methodologies and technologies inspired by manufacturing practices, aiming to streamline efficiency, improve quality, and reduce cost across the construction industry. The key aspects of industrialization in the construction process are, first of all, prefabrication and modular construction. Prefabrication involves manufacturing building components off-site in a controlled environment and then assembling them on-site, while modular construction takes this further by creating entire sections of modules of a building off-site and transporting them for assembly. This approach reduces construction time, minimizes waste, and enhances quality control. The second aspect, the standardization of components, such as structural elements, mechanical systems, and finishes, can facilitate mass production, lower cost, and simplify construction processes. This involves using common specifications, dimensions, and materials across projects whenever possible. The third one, automation and robotics. Automation technologies such as robotic arms and 3D printing are increasingly being used in construction to perform repetitive tasks more efficiently and accurately. Robotics can be utilized for tasks like bricklaying, concrete pouring, and material handling, leading to faster construction timelines and improved safety. Next, digitalization and building information modeling, BIM, which involves creating digital representations of buildings and infrastructure, allowing for collaborative design, visualization, and simulation throughout the project lifecycle. Digital tools enable better coordination among project stakeholders, improved decision-making, and reduced errors and rework. Lean construction principles, borrowed from lean manufacturing, focus on maximizing value and minimizing waste throughout the construction process. This involves techniques such that as just-in-time delivery, continuous improvement, and eliminating non-value-added activities. Off-site construction and assembly. Off-site construction involves performing construction activities away from the project site, often in a factory or workshop setting. This approach can improve productivity, quality control, and worker safety by providing a controlled environment and specialized equipment. Joseph, what's your point of view on the topic?
Industrialization of the construction is a key trend for the next couple of years in our industry. To reach our main target, build better and faster with less impact on the planet. The only way to do better in the fastest way is to stop applying manual and non-scalable workflows and shift to mass and industrialized production. Rawad, you mentioned several important points: prefabrication and modular construction, standardization of components, automation and manufacturing, several topics which are really the core of our product strategy for the next years. In our existing portfolio, we already have products enabling the industrialization of the construction industry. For example, MWF, which is our framing solution in Revit, able to automate the panelization of an entire framed building, considering fabrication constraints right from the design stage. When the detailing is ready in Revit, for manufacturing, we can link to our cloud solution Onyx to produce tags, stack and bundle the panels to be delivered on site. With those solutions, we really support and complete workflow from the design to manufacturing. But we want to go further. We are also working on a new cloud-based platform dedicated to the industrialization of the construction, and able to bridge the gap between the design and the manufacturing, sharing those industrialized components between the different stakeholders of a project. We are convinced that the workflows we applied on frame structures with MWF and Onyx can be extended to the other sectors of the industry: stairs and railings, rebar, precast, timber. We want to design the off-site fabrication management platform for the entire construction industry. I would like also to mention a very important initiative from Autodesk. Thanks to its MID initiative, which stands for Manufacturing Informed Design, Autodesk just launched in February a new solution called AID, standing for Autodesk Informed Design. This idea is very powerful, considering the manufacturing constraints and possibilities as early as possible in the design phase. This new way of working totally changes the way we design a project. It improves design quality, it reduces rework and delays, and it increases workload capacity thanks to a significant boost of productivity. Basically, you can create manufactured components with their own data, with defined variable parameters. You can create those components in Inventor, export them using the AID plugin, and import those components in Revit to be used for the design step by the architect or any other professional. We are working closely with Autodesk to integrate our solutions in their ecosystem. Let's now talk about data and software in the cloud. When dealing with a construction project, construction professionals are generating a lot of data: 3D models, parametric objects, reports, drawings, quantity takeoffs. And it is crucial to share this data all along the complete design chain. In the last years, with the BIM era, we talked a lot about interoperability, exchanging models, geometry between different platforms, using open BIM formats like IFC or specific ones. This is a good evolution, but it is not enough. The professionals need to share data, contextualized data depending on their needs. The face of construction is changing. The demand, the nature of the demand is changing as customers develop new and different expectations driven by their greater access to information. Projects are changing. Themselves are being redefined with greatly expanded capabilities and implications for business models. Technology in the construction is changing dramatically and impacting the ways architects and engineers both develop and design projects. Data is growing exponentially and becoming more complex. 90% of the data today has been created in the past 2-3 years. Construction projects are much more data-driven. During the construction cycle, but also during the complete life cycle, data is important for owners, facility managers to be able to anticipate and plan the maintenance of their buildings, optimize their efficiency from the sustainable point of view, for example, reduce the carbon footprint of the building. As we are convinced about the importance of data, we have an ambitious product strategy around this topic. In Q3 last year, we just launched a new product called Data Connect, with several objectives. ERP integration between different platforms, especially between Autodesk Construction Cloud and ERP systems. File sync to synchronize files between local machines and cloud platforms. And a new migration tool. With Data Connect, we target all professionals of the construction industry. Again, owners, architects, engineers, general contractors, property managers. We want to ensure the data continuity from design to plan, to build, to operate. We have several objectives in mind. Reduce the integration complexity between platforms, which is often a data breaker. Increase the security with a highly customizable cloud platform solution. Remove duplicates entry. Get a single source of data, a single source of truth. We also started our journey to cloudify our solutions and allow our customers to access their tools from everywhere. The objective is not to go cloud with all our products, which makes no really sense. We want to focus on topics where cloud brings a real added value. For example, as I mentioned before, we aim to provide a cloud-based platform for fabrication management. We want to empower structural engineers with cloud-based engines, even AI-powered, to predict the behavior of structures, optimize the design using generative design, analyze several solutions within a few seconds, access their data, results, reports in the cloud, and much more. Cloud and data are related. Cloud is about collaboration and computing. Rawad, do you want to say a word on that?
Thanks, Joseph. Indeed, I would like to differentiate between 2 points. Cloud-based collaboration and data management that enable communication and cooperation among stakeholders involved in construction projects. Some software providers offer already mobile applications for visualizing structural analysis results, enhancing accessibility for structural engineers and on-site technicians. And the second one, the cloud-based computing. It provides a flexible and well-equipped environment for engineers to design and construct buildings, leveraging high-performance computing resources. Web APIs facilitate seamless communication between structural analysis and design software, allowing engineers to automate tasks through software code. Centralized operations offered by cloud service providers eliminate the need for individual clients to manage software versions and licenses, leading to improved efficiency and cost effectiveness. Ladies and gentlemen, Joseph, here we come to the end of this session. From the challenges of sustainability to the transformative power of technology in our industries, each contribution will enrich our understanding and inspire new ideas. As we leave this session, let us carry forward the spirit of collaboration and innovation. Let's continue to seek solutions, build connections, drive positive change in the AEC fields, and build a sustainable future. Meanwhile, Gretec will continue modeling the future. Together, we can create a brighter tomorrow. Thank you.
Thank you, Rawad, and thank you all for joining this session. Let's embrace the future with all those new technologies that will help all of us, construction professionals, to build better and faster. As a software editor, we breathe innovation and technology every day, and we do our best to offer you the best solution answering to your current and future needs. It's vital for us to get feedback from our users, from you, so do not hesitate to contact us and give us feedback, insights on your needs, difficulties, challenges. So now it's time for question and answers, so please use the chat, place your questions, and I'm here with Rawad. We are here to answer all your questions. Thank you.
Okay, so hello again, everyone. So please feel free to place all your questions on the chat, on the live chat, so you can place the questions, and I will, with Rawad, we will answer in live. So please do not hesitate. So just looking if there are some questions coming. Okay, so for the moment, I see no questions. So hope everything was clear. Again, those are important topics. Some of those topics will come in the coming months, in the coming years, in our products, and we we really aim to support this shift of the construction industry, embracing those new features. So, okay, so I saw, for example, on the polls that okay, most of you, almost 80%, are really concerned by industrialization in your projects. That's a very important insight for us. I see also that a big majority of you, more than 80%, 83% exactly, are really convinced that AI will revolutionize the structural engineering in the upcoming months and years, so very short term. And also something interesting is that 66% of you, of the people who answered the poll, do not have today a dedicated tool to manage the project's data, which is something I think to be changed in the future, because really data is super important in all the construction projects. Okay, so I see for the moment no questions. Okay, so no questions coming. Okay, so if there are no questions coming, again, thank you for attending this session, and really please do not. Okay, there is a question. Which is telling me there is a question, but I don't see it. Don't see it on the chat. I have the feeling that I do not see. Okay, now I see. What areas of structural engineering does AI struggles to be integrated to? In fact, AI for structural engineering, the complexity is really to collect the data. That's really the core, because, for example, we mentioned predicting the results. If we want to predict the results, what it means that predicting the results needs to be done without doing any calculations, okay? Because else it's not AI, it's something else. So if we want to predict results, it means that we need an important database with a lot of data about already calculated projects. And this is the biggest struggle for us, is to build this data from existing projects. So that's the main point. Of course, then there are some applications where AI will come soon, as for example, helping users to access any kind of documentation, for example, or technical support, to really better interact and onboard on a product, on a software. That's something quite easy to do, that we started to work on. But yes, the biggest difficulty is to build up the data to feed those algorithms. And really, we think that predictive analysis is a key topic to really help the engineers to go much faster and to deal with their projects at the early stage. Just checking if there are some other questions. Okay. Thank you, Lukasz, because I think I have an issue on the chat. I don't see the question. So how can AI revolutionize FEM software's features? Okay, yes, I mentioned predictive design. Of course, there are some, which for us is one of the main topics and maybe the most difficult one. After, there are also some other functionalities that can be revolutionized by AI, like, for example, automating a lot of things that can be, for example, if the software, if the technology is able to understand that you are building, that you are designing, calculating a building, a residential building, then a lot of automations can come with, like, for example, applying automatically loads because the AI can guess that you are in a circulation, or you have a meeting room, or you have a stairs, or and all those loads applied depending on the location and the use of the room. As you all know, as structural engineers, it's code driven, so we know that we have to apply 1.5 kilonewtons per square meter on a flat, 2.5 kilonewtons per square meter on circulations. So AI can come there to automate a lot of things. For example, generating reports, it's the same. AI could help to really generate outputs, documentations much faster than what we can do today. Even if today, I'm now talking about advanced design, it's quite fast, but we can go even faster and, in fact, limit repetitive tasks that are time consuming and, let's be honest, quite boring for structural engineers. Okay, I see another question. Will it have any impact on drafting, or will it be able to provide kickstart, conceptualize the ideas, and then later we can mature that idea? Yes, of course. That's also a good point. AI can help to what we call design, or help on the concept of a project. Yes, and it can also help again on the output. But okay, I talked about reports, but AI can also automate, for example, on a drawing. Again, repetitive tasks. For example, you create a drawing, you have to put a lot of tags, dimensions on the drawing, and detailers or drafters are losing a lot of time on placing, moving tags to not have overlapped tasks. And again, AI can really accelerate a lot and produce super fast, very clean drawing. So yes, AI can, and again, back to the predictive. So I talked about predictive results, but it can also be predictive design, because as soon as we have a good database, when you are starting to model, for example, you are starting to model a building, AI could really help the engineer from the structural point of view. I don't know, for example, imagine you start to create a shape, 1, 2, 3 levels. So from a few inputs, an AI algorithm can start to create walls, columns. If you increase the span or you increase the dimensions of a slab, the height of the beams are growing, the thickness of the slab increase, things like that. Again, based on data, so it's a kind of prediction as well, but predicting the geometry, not necessarily the FEM results. So that's two topics, but linked to this concept of prediction, helping to design faster. Okay, I see another question. Do you think AI could eventually generate a design from the 3D scan without manual input? I think AI can generate a design. It depends what we mean with design. We have to be careful, because in English, design means really the conception, while sometimes design might mean also the calculation. So Bethan, I don't know what you mean with design, but if it's conception, okay, an existing structure, yes, okay. So in this case, yes, AI can. The difficulty, there are some companies who already started to try to automate the geometric creation from a cloud point, and it's a super complex topic, to be honest. Us, for example, what we are thinking about, it's not exactly what you said. It's more to start from a model, for example, a model in Revit, but I'm mentioning Revit can be another BIM platform, and from a geometrical model, being able to extract what we need to create what we call the analytical model. So to automatically create the model that the engineer will be able to calculate. So it's not exactly what you asked. Creating 3D geometry from cloud points, for sure. At the time being, we, as far as I know, and of course I'm not aware about everything which exists, but It does not exist yet. Many companies tried already. It's not that successful for the moment, but for sure it will come. For sure it will come because it's a real topic, especially for the renovation and the retrofitting topic that we talked about with Rawad. Definitely having a solution able to convert a 3D cloud points into a real geometry that can be used either by the architect or the structure engineers, or all. Yes, it would be really beneficial for sure. Yes, thank you, Ahmad, for your message on the chat. I don't know if there are some other questions. Really, please feel free. We'll just look if I did not miss a question. Okay, seems no other questions. Okay, so if there are no other questions, thank you for joining. I hope you registered to other classes. We have a lot of super interesting classes, so really do not hesitate to browse the agenda to register to other classes. A lot of amazing content. I'm staying at your disposal. I'm talking behalf for Rawad. You can really ping us. Do not hesitate. You can quite easily find our coordinates even on LinkedIn. So please contact us, join us. All the insights are super useful for us. I did not introduce myself so much, a little bit at the beginning of the video, but as you know, I'm the Chief Product Officer of the group, so I'm dealing with the product strategy and roadmaps. So really, all insights are super important for us. So do not hesitate to ping us and share with us all ideas you might have in the real life doing real projects.
Thanks, Joseph. Sorry, I tried before to join to speak, but I had some troubles, to log in as a speaker. So thank you for answering those questions the best way as usually. And I was so glad to hear all those questions and to see the number of engaged audience. So really wonderful result. And as Joseph said, we are here to answer your questions, but even later, you can find us on LinkedIn or any other way by sending an email. We'll be happy to exchange with you, to communicate with all of you.
Yeah. Thank you, Rawad. Thank you all. Enjoy this Innovation to Build event. And of course, we stay at your disposal and we stay tuned.
Thanks, Joseph.
Thank you very much.
Bye-bye.
Thank you all, and enjoy the event. Thank you. Bye-bye.